At Boston Children's Hospital, we are the last hope for some of our patients. And yet, even the potentially curative treatments that we can offer come with tremendous risk and tremendous toxicity.
For many of our patients with rare blood diseases or with cancer, a bone marrow transplant would actually be curative, but it's very, very hard to find a match of their immune system.
Daniel was born with floppy thumbs, both, and his left ear was cauliflowered.
Daniel has a devastating disease called Fanconi's anemia. And this is diagnosed shortly after birth when there are certain developmental milestones that simply aren't met.
And unfortunately, their bone marrow depletes to the point that they will have leukemia unless they get a bone marrow transplant.
I've had over hundreds of surgeries. I've had them opening up my right ear. I've had them tightening a muscle, my primary muscle up here. I've had to spend half my life in the hospital, I would guess.
Unfortunately, they had already been looking for a match for Daniel, and they hadn't found anyone yet. So we decided to do in vitro fertilization with pre-genetic testing so that the embryos would each be tested to see who's a match and who has Fanconi's.
One of the issues with marrow transplant or cord blood transplant is that 25% of patients die from the procedure. So we need to develop better ways of doing the process to match the grafts perfectly and to find ways that the engraftment process can actually work better.
And the way we can do that is by making it a transplant from their own cells. To take their own cells and reprogram them back to an embryonic-like cell. From this embryonic-like cell, we can then coax the formation of normal blood stem cells.
Every organ of your body has rare cells in the organ that have the ability to remake the organ. Those cells are stem cells. What we're trying to do is to put in stem cells into diseased organs, and those good stem cells would actually rescue that organ in terms of its function.
This is not an easy problem. My lab's been working for over 2 decades on learning how to coax these primitive pluripotent stem cells along their pathway to become specialized blood stem cells.
About 4 or 5 months ago, we had a discovery that was published in a very prestigious journal, Nature, and that shows a pathway to make the blood stem cell.
We're able to make human blood stem cells enough to transplant a mouse, which only weighs about a couple ounces. We'd have to scale up about 400-fold to be able to make those cells transplantable for a human patient.
The field is really moving very, very rapidly, and we're just at the beginning of seeing this massive influx of clinical trials and hopefully ultimately great therapies as a result of this stem cell work. If you think about how stem cells could be used to take healthy cells and put them in a diseased organ, it extends to many common diseases where millions of patients have these diseases, diseases like Parkinson's and diabetes. So the Boston Investment Conference has a huge impact not only on the study of pediatric rare genetic diseases, but on how all diseases are actually going to be treated in the future.
I think it's amazing. I'm all for it because I was in the shoes of wanting to desperately help my child in any way, shape, or form I could. Really, if they can do this, I think it'll save a lot of children heartache and pain.
I'm very grateful for Children's Hospital saving my life, and hopefully they will save many more.